Okay, so here we have a question where they're giving us a graph. They're starting off with a graph, and they want us to work backwards to the equation. It's kind of funny. Okay, so they give us a graph, and they want us to work backwards to the equation. How are we going to do it? Well, first off, let's um, let's start by identifying the centers right here. And what's the coordinates of that? It is 3, 2. Center is 3, 2. Okay, so we got the center. Now let's look. If you look at the notes, let me show you from the notes. This is from the exam 5 notes. Graphing a hyperbola not centered at the origin. So how do you graph a hyperbola not centered at the origin? Well, the center is the opposite of the numbers next to x and y in the original equation. See how we have a +7 next to x, and the center is actually -7, and a -2 next to y in the original equation, and the center is actually, the y value is +2. It's opposite, right? That's just the same way it was for the ellipse. It's exactly the same. So whatever, and it's throughout the course, right? Always, whatever's in the parentheses next to x or y is the opposite on the graph. So remember that. So let's use that back here. So we're saying, oh, okay, well, if this is the center and this is like x and y for the center, then the real equation is going to be x minus 3 squared over whatever a squared minus y minus 2 squared over b squared equals 1 so far, right? See what I'm doing there? So far so good. I'm just thinking, well, it's opposite. So this is a +3 and a +2. And so this has got to be opposite -3, opposite -2. So from the equation to the graph is always opposite. So what opposite of -3 is +3 on the graph, -2 +2. All right, so we got that. Now, how do we know if x goes in the front or y goes in the front? I mean, I just wrote x in the front, but is that really true? Well, remember, if x squared is positive in the front, the branches go right, left. If y squared is positive in the front, the branches go up, down. So what's in the front and positive tells you which way the branches go. Y goes on the y-axis, x goes on the x-axis. Okay, so what do we have? We have branches going right, left. So that's right then. By luck, by random luck, I've got it right. So x squared is positive in the front because the branches, at least the one I got, are right, left branches, which is an X kind of thing, right? The X-axis goes right and left, X should be in the front. That makes sense. Okay, got it. Now, how am I going to find the A and the B? How do I find the A and the B? Well, you go back down to the, again, the notes. Graphing a hyperbola, not centered at the origin, not centered at the origin. Notice from the center, go right and left the square root of the number under x. Ah, that's what I'm looking for, right? That number underneath x here. That number, the square root of it, ends up being this amount that goes to the right. And of course, it's also 3 to the left. And the number under y ends up being the amount you go up, and also same thing down, for this dotted box. Now, wait a minute, I've got to get that dotted box thing. How do I get that dotted box? Well, it's got the box, notice, is right where the vertices touch the graph. Right here and right here is the edges of the box, huh? So let's go back and do that first off. So, okay, so that's going to be, right, let me change the color so it's clear. Right here and here. That's where the box must be. Well, how do you know how? So the box must go straight up and it must hit right here. How do you know? Because that's where it hits the asymptote line. And straight down, boom, right there. And straight over, boom, right there. And straight down, boom, right there. How did I know? Because the asymptote lines have to be going through the corners of the box. Remember? The asymptote lines always go through the corners. Let's take a look at the graph. See right here, see how the asymptote lines go right through the corners of the box. So therefore, you can find, if you know the box begins right here, the branches touch the middle of the box, then you just go up and down, and as soon as you hit the asymptote line, that's the corner, right? Go up, hit the asymptote line, that's the corner, go down, hit the asymptote line, that's the corner, and then just connect them. So I got the box, okay, great. So what does that mean? Well, that tells me, looking at the box, that this is from here to here is over 1, isn't it? And here up to here is up 3. Do you see that? The box goes right 1 up 3. See right here on this graph, on the notes I'm giving you. See how this number over 3, that's the number under x, but you got to square it to go back to 9. See that? So from the very middle of the box to the edge where the branch hits, that number squared is what goes underneath x. So we go, oh, so this number squared is what goes underneath x, and this number squared is what goes underneath y. Is that making sense? Let me go back to the picture one more time. Right? The number from the middle to the top of the box, that number, let me get a little more room here. That number from the middle of the top of the box squared is what goes underneath y, right? Because vice versa, you rooted it. It's the opposite. So we just look at the box. We say how far from the middle of the box over that number goes on squared goes underneath x. From the middle to the top of the box, that number squared goes under y in the equation. We go, oh yeah. So then this equation becomes x minus 3 squared over 1 squared minus y minus 2 squared over 3 squared is 1. And then we can simplify that. This is just going to be x minus 3 squared. We don't even need to write that because 1 squared is just 1, which we don't even need. Divided by 1 doesn't do anything. Over 9 equals 1. So there it is. That's what we're going to put in this box. That's the standard equation for the hyperbola that is graphed there. So there we go.